We are going to work on inequalities for 9.5 part 1. We're going to work on writing them. So this is a word we have heard before, inequality. We know that means not equal. So an inequality is comparing two numbers that are not equal, and it uses the greater than and less than symbols. So they are not equal to each other. So we have solved many of these before. We're going to practice writing them from a story problem though. So a solution of an inequality is a value that will make it true. And now the thing is, we're not just saying this equals this. We are saying, right, this is less than this. There's so many things that could be less than that. There's not just one answer. So it's a solution that makes it true. And then taking that a step farther is we can also have a solution set. So if I have a set of something, that means I have more than one of them. So a solution set is going to be at least 3 of those values that make it true. That will help us reason through which way should the symbol go. It's going to help us with our next lesson. So when we ask for a solution set, you're giving me 3 values at least. You can do more, but you have to do at least 3 that will make that inequality true. So our first symbol is a less than sign, and it's like we read it. We come to the little side, and then here's our big side. This is less than this side. These are not alligators. We're not putting teeth in them. This is a math symbol. This is a less than sign, right? This side is smaller than this side. It's less than this side. So some words we need to know that might represent less than. It might not always just say this is less than. It might say it's fewer than it. It's below it. It's underneath. So those are just a few options of things we might hear that are less than another value. Our next symbol is greater than. So as you read it, you come to the big side first. This side is greater than this side. So it's pointing to the little one. This side is greater than this one. Some words you might hear to represent that are it's more than, it's above it, it's over it. All of those are saying that it's greater than the other value. So those are ones we are pretty familiar with. So some new ones is we have less than or equal to. So you can see here is the less than sign. It's less than, but it also has this part of an equal sign, right? It's half less, it's half equal. Less than or equal to. Now these words can get tricky when you read them. Most, more, max. Those sound like they're big, but we've got to read them and understand, right? It's at most. That's the most it can be. So it's anything less than that. That's the most it could be. It is no more than this, right? That's the most it can be. It's anything less than that. This is the maximum. This is the most it can be. So they sound like big words. They're actually the opposite. They're saying that's the biggest it can be, and it's anything less than that. So you really have to pay attention and think about what do those words mean. You can't just say, oh, most is bigger. No, that's the biggest it can be. It's actually less than that. And then our last symbol is a greater than or equal to sign. So again, we have the greater than sign and then half of an equal sign. So it could equal it, or it could be bigger, right? We have a lot of options that it could be. So again, we're going to hear little words. It's the least, it's less, it's the minimum. And those sound like, oh, those will be less, but it's at least that. That's the least it can be. It's actually bigger, right? At least more. No less than this. It cannot be less than this number. It actually has to be bigger than that. This is the minimum. I need more than that. So we've got to really think about these words as we're using our less than or greater than or equal to signs. So when we've got that equal, we've got to think about doing the opposite. I hear least, but that actually means that's the lowest. It's got to be bigger. And then as you're writing these, you always want to ask if it can be that amount. Can it equal that number? Is that a solution that could make it true? Could they be equal, or is it just less than or greater than? So let's practice one here. So anyone that was at least 19 could go to the dance. Write an inequality and a solution set. So this is a little different than ones we've done. Usually we have two numbers and we're comparing them. All we have is 19. So we know there are lots of people that could go to this dance. So it doesn't say just 19-year-old students. So we're going to pick a variable. The variable is not important what the letter is, but it's important that you have one. So I'm going to pick D for going to the dance. So it won't really matter what you pick, but you've got to pick one. You could pick A for anyone. You could pick A for age. You could pick P for people. So the letter is not important, but it's important that you have a variable. So I'm picking D for dance. And I am comparing that to 19. So I'm going to leave a little space in between them. So D and 19, this is what I'm comparing. I know they are at least 19 to go to the dance. If I look back at my keywords, that tells me that that's the lowest they can be. They can be 19, but they could also be greater than that. So we're going to write this solution set. So out to the side, I'm going to put 3 lines, and I need to put 3 things that can make D true. How old can someone be and go to the dance? Now, there are so many options. We're just saying here's 3 of them to help think about this. So we always want to stop and ask, can it be 19? Can someone who is 19 go to the dance? That's the lowest they can be. So yes, if they are 19, they can go to the dance, right? So that's the least they can be. So we need people that are older than that. So can someone 25 go to the dance? Yes. Can someone 47 go to the dance? Yes, that's at least 19. I'm going to just check, what if they're 18? Can they go to the dance? No, they're not 19. To be 19 or older, that's the least they can be. That's the lowest they can be. So if they're younger than 19, they will not let them into the dance. So I'm going to start thinking about my symbol that's going to compare them. They can equal 19. So I'm going to get that equal sign there. And then I'm noticing that these are greater than 19. So if I'm comparing it, these are greater than 19. 19 is less than. So if I read my inequality, D is less than, sorry, I said that backwards. D is greater than or equal to 19. So anyone who is equal to 19 or older can go to the dance. So I find my variable, find the number I'm comparing, set it up. I write my 3 solutions, thinking about my keywords and asking if it can equal that number. And then I fill in my symbol here. So go ahead and write yourself a note about something you can remember about writing inequalities.